Section 2.5 is an introduction to problem solving. In the first objective, we're looking at English phrases that can be directly translated into mathematical phrases. For example, a number increased by 60. A number is my unknown. Increased by is a word for addition. 60. That would be the mathematical translation. In part B, a number decreased by 23. So my number is going to be decreased by 23. That's not an order switch here, just that number needs to be decreased by 23. Again, the product means multiplication, so the product of 7 and a number, written as 7 times x. The quotient of a number and 19. The quotient is a division word, so quotient of a number and 19. And finally, twice the sum of a number and 4. Twice means 2 times. It's twice what though? Twice the sum, so it's 2 times the sum of 4 and a number. Those parentheses are very important right there. It's not 2 times 4 or 2 times a number, it's 2 times or twice the sum, that entire sum. Okay, let's look at the next objective. The next objective is to solve algebraic word problems using linear equations. These problems are going to be ones that are going to require me to read carefully. They're not going to be directly translatable like a couple above right there, but I'm going to be able to translate them by reading them carefully, by writing in the expression in terms of the unknown quantities, and then I will solve the equation, and so on. Let's look at the next page. Alright, so here we have an example. If the quotient of 3 times a number, okay, this one's pretty mathematical again. So if the quotient of 3 times a number and 5 is increased by 4, the result is 34. Okay, so in this one, my variable, I'm just going to say x, and it's going to be the number, so a number. You can choose whatever letter you'd like. You don't need to use x, you can use n, whatever letter. Alright, so in my equation, the key words here, I want to look for my equals, and the result is, it's a good spot for the equals to be, so the result is 34. Alright, so I know one side of the equation already. Let's look for the other side. If the quotient of, and here are the two parts of the quotient, one of them is 3 times a number, and the other one is 5, so the quotient of 3 times a number and 5, so I'm going to write that as 3 times a number and 5 in a quotient, is increased by 4. Increased by is a word for addition, by 4. The result is, that's my equals 34. Okay, so that's how I would write this equation. So this one, yes, was very mathematical in its translation. I can see, let's see, the next one right here is going to be a little bit more English-based, and I can do the translation. So let's go ahead and solve this equation. 3x over 5 plus 4 equals 34. When I begin to solve it, the first step is going to be identify where x is, work away from it. This is plus 4, so I need to subtract 4 from both sides. So 3x over 5 equals 34 minus 4 is 30. The next step will be to say this is 3 times x divided by 5. So we're going to multiply both sides by 5. Alright, that's going to give us 3x equals 30 times 5 is 150. And last, 3 times x, so we're going to divide both sides by 3. So that'll give us x equals 50. So to interpret the results, the number is 50. We're just looking for the number right here, and we have found it. The number is 50. Okay, so let's look at the next example. In the next example, we're looking at page numbers on facing pages of the book. They're consecutive integers. 2 pages that face each other have 629 as the sum of their page numbers. What are the page numbers? So first of all, what I need to think about is if page 1 is x, what would page 2 be? Since they're consecutive integers, and I know how books work, if one page is like 520, the next page is 521. They're consecutive integers, meaning that if one of them is x, the other one is one more. X plus 1. That's what consecutive integers mean, and I can pull that knowledge from my knowledge of how books work and how page numbers in books work. One page is going to be one larger than the other. Okay? Now, the two pages that face each other have 629 as their sum. Their sum means if I add up these two page numbers, I'll get 629. So my equation should be x plus 1. So I have here the first page plus the second page equals the sum of 629. So that would be how I would create my equation here. And then we will solve it. So to solve it, let's go ahead and add up our like terms. X plus x is 2x plus 1 equals 629. Then to solve for x, we're going to start by subtracting 1 from both sides. 2x equals 628. Opposite of multiply by 2 would be to divide both sides by 2. I need to write it over here. When I divide both sides by 2, x is going to be equal to 314. Alright, I had two things I was looking for here. The page numbers. This right here is page 1, and page 2 was x plus 1, which would be 315. So the page numbers are 314 and 315. So I've written a little bit of shorthand right there. The page numbers are 314 and 315. Let's look at the next one. In the next example, a car rental agency charges $200 per week plus 15 cents per mile to rent a car. How many miles is the question? How many miles can you travel in 1 week for $320? So my variable, the thing I need to find, is how many miles. I'm going to use m this time. And it's going to stand for the number of miles that I can travel. Alright, so let's put the two parts of the equation together. They're going to charge me $200 per week. They're also going to charge me 15 cents per mile. And I know that it's going to total $320. The $200 per week, they're going to charge me no matter how far I drive. Then they're going to charge me 15 cents for each mile I drive. So 15 cents times the total number of miles I drive. That is going to be the total fee. And I want to find out how many miles I'd have to drive for this to be equal to $320. So that's going to be my equation. You can kind of hear how I built that up. I knew I was going to have $200 anyway. And then the part that depends on the miles, with the variable here, is at 15 cents per mile. Now I need to solve. So 200 plus 0.15 m equals 320. When I want to solve for m, the first thing I need to do is subtract off the 200. So I get 0.15 m equals 120. And then we'll divide both sides by 0.15. So m is equal to 120 divided by 0.15, 800. So we can drive 800 miles for $320. Now, looking back at this example, what I want to highlight here is the important thing really is writing this equation. The goal in this section, the goal in this course, is to be able to write an equation and solve the equation. I know sometimes we're tempted to try to just find the answer. We think getting the answer here is the goal, but that is not the case. The most important part of this section is developing the skills to write an equation, then solve the equation to get the right answer. So let's make sure we practice the actual act of writing the equation. Let's look at the last one here. Including a 6% sales tax, a car sold for $23,850. Find the price of the car before the tax was added. Okay. So let's see. What I want to find is the price of the car before the tax was added. So let's say C, for example, is going to be the price of the car. Now, how do taxes work? Okay, I know that multiplying a 6% sales tax by the price of the car is going to give me the amount of tax, right? If I take 6% times the amount of the car, that's going to give me the amount of the tax that I have to pay. Then you have to add on the original price of the car, right? To get the total with tax. So we're using our knowledge of percentages from the last section, what we know about tax. This is the original price of the car plus 6% times the car gives you the amount of tax you have to pay. So to solve this equation, 0.06c plus 1c would be 1.06c. Adding those two like terms equals the 23,850. Now I've got 106 times c, so we need to divide both sides by 1.06. Alright, so we need 23,850 divided by 1.06. $22,500. So C is $22,500. And in my interpretation, I can say the car costs, make sure I put $sign on here for units, $22,500 before tax.